So our next electrophilic substitution we're going to look at is called alkylation. So remember that an alkyl group is an R group. So to do this, we're going to use an R group and we're going to attach it to a halogen. So we're going to use a halogenoalkane. So let's have an example. Let's take our benzene and let's use, I don't know, CH3CH2Cl. Now we're going to add the R group. Now it's not going to get added via the CH3, that's got to be the end, so it's going to get added via the CH2. We're going to make ethyl benzene in this case, and we swapped for H, so we've made HCl. So how do we generate the electrophile? Remember, we put our hand over the benzene ring and we see what our electrophile is. So remember, our electrophile is going to be a CH2CH3 with a plus. How do we make that? We're going to make that from our halogenoalkane, CH3CH2Cl. We're going to use AlCl3 again. In fact, it's only the nitration that uses a different catalyst. Every other reaction is going to use this AlCl3. AlCl4 minus. Then we're going to do our curly arrows, so see if you can have a go. So I'm going to put it to this side this time, just for a bit of difference. Can you do the mechanism? I'm going to put it into this position, the second one here, this one here, when I do it. But see if you can do a mechanism. So there you go, did you get that? And then can you regenerate the catalyst? So the H plus that's been generated in that middle step reacts with the AlCl4 minus to give us the AlCl3 back, the catalyst back, and HCl. So alkylation, and we could do that with all sorts of different alkyl groups. So they could be branched. So as long as you start with a halogenoalkane, remember, just put your hand over the benzene ring. I want to stick that thing on. How am I going to stick it on? You put a Cl where the bond to the benzene is.